Most people assume that safe drinking water is a modern achievement, something made possible by electricity, industrial chemistry, and stainless steel treatment plants. The common belief is that before chlorination and centralized infrastructure, water was simply unsafe, and people survived by luck or hardened immune systems. That assumption is not only wrong, it obscures an uncomfortable truth. Many ancient societies developed filtration systems so effective, so resilient, and so elegantly simple that they continue to outperform modern systems under stress, especially in war, disaster, and collapse. When centralized treatment fails, modern cities become thirsty within days. But civilizations without pumps, plastic membranes, or grid-power designed water systems that function passively, continuously, and locally. In medieval Sri Lanka, massive tank systems supported large populations in dry zones. The reservoirs were not simple ponds. They incorporated spillways, sediment traps, and controlled outlets designed to manage both quantity and quality. Silt settled before water reached inhabited areas. Maintenance was communal and continuous. These systems endured for centuries because they were repairable with local materials. Compare that to a modern membrane filtration unit that requires imported components and technical expertise. Under normal conditions, modern systems are superior in precision. Under disrupted conditions, ancient systems are superior in durability. Charcoal filtration, often marketed today as a modern innovation, was well understood in the ancient world. Greek and later Arabic scholars documented the use of charcoal to improve water quality. In Japan, a similar understanding led to the use of binchotan charcoal in water vessels. Charcoal's porous structure adsorbs organic compounds and certain toxins. While it does not remove all pathogens, when combined with sedimentation and sand filtration, it significantly improves potability. What matters is not any single method, but the layering: sediment removal, sand percolation, charcoal adsorption, storage in cool, dark containers. Each stage reduces risk. Modern survival manuals rediscover these principles as if they are novel. They are not. They are refinements of practices that predate industrial chemistry by millennia. When warfare disrupted centralized systems in the 20th century, these older methods quietly resurfaced. During both world wars, armies confronted the vulnerability of modern supply lines. Chlorination became standard military practice because it was portable and fast. But in static trench systems and remote theaters, soldiers often supplemented chemical treatment with improvised filtration. Sandbags layered with charcoal, gravel-filled barrels, and slow-drip filters constructed from available materials. In the Pacific theater, where tropical rainfall was abundant but contamination risks were high, filtration combined with boiling became routine. Soldiers who understood sedimentation and pre-filtration reduced fuel consumption because clearer water required less boiling time. Later, in Vietnam, the United States military deployed small-unit water purification systems, but field manuals still emphasized source selection and natural filtration awareness. Even advanced technology did not eliminate the need to understand terrain and hydrology. Modern humanitarian crises reinforce the same lesson. In disaster zones where treatment plants are damaged, aid organizations frequently construct slow sand filters. These systems, essentially scaled versions of ancient designs, use biological layers, known as Schmutzdecker, to trap and consume pathogens. Properly maintained, they can produce high-quality drinking water for communities without electricity. The effectiveness of slow sand filtration is not theoretical, it is documented and measurable, and it depends on patience, not speed. Water moves slowly through fine sand, allowing biological processes to occur. Ancient systems favored resilience. There is also a psychological dimension to decentralized filtration that modern infrastructure often neglects. When water treatment is invisible and centralized, populations lose practical knowledge. They assume that turning a tap is equivalent to safety. In ancient societies, water management was visible and communal. Cisterns were cleaned, sediment was removed, charcoal was replaced, knowledge was distributed. This mattered in times of crisis. When siege, drought, or invasion disrupted supply, communities retained the technical literacy to adapt. Today, many urban populations lack even basic understanding of sedimentation or filtration principles. Preparedness becomes a matter of purchasing equipment rather than understanding process. For survival-minded individuals, this distinction is not philosophical, it is operational. A ceramic filter with a cracked element becomes useless. A gravity-fed sand and charcoal column can be rebuilt from local materials. A chemical supply chain can be interrupted. A riverbank cannot be embargoed. This does not mean modern treatment is inferior in normal conditions. It means that performance must be measured against context. Ancient engineers designed for continuity in unstable environments because instability was common. They expected siege. They expected seasonal drought. They expected political upheaval. Modern urban systems, by contrast, assume stability, stable power, stable governance, stable logistics. When those assumptions hold, the results are impressive. When they fail, consequences cascade quickly. The deeper lesson is not that we should abandon modern treatment. It is that we should not forget older principles simply because they lack stainless steel housings. Water clarity precedes water safety. Sediment control reduces disease. Layered filtration outperforms single-stage solutions. Decentralized knowledge strengthens resilience. These were not abstract theories, they were conclusions drawn from lived experience, often paid for in lives lost to preventable illness. History shows repeatedly that water insecurity reshapes conflict outcomes and population survival more reliably than tactical brilliance. Armies collapsed from contaminated wells. Cities surrendered when cisterns failed. Communities endured when they managed water intelligently. Understanding ancient filtration is not nostalgia, it is strategic memory. When we study these systems carefully, we see a pattern. Simplicity paired with ecological understanding produces durability. Sand, stone, charcoal, gravity, time. No patents, no proprietary membranes, no reliance on distant factories. In an era increasingly defined by complex supply chains and fragile infrastructure, that pattern deserves serious attention. If you value history not as trivia but as instruction, if you believe that preparedness begins with understanding rather than equipment, then these overlooked systems matter. They remind us that resilience is often quiet, unglamorous, and built long before crisis arrives. Subscribe to the Prepper Historian if you want more of these deeper examinations of the past. Less about spectacle, more about systems that determined who endured and who did not. And share this video with others who understand that history's most important lessons are rarely the loudest ones.